Solve the initial value. Okay, let's do number 7 first. Okay, solve the initial value problem. Dy over dx is equal to x6 times y minus 2, y0 is equal to 4. Initial value problem is just a differential equation where we are also given an extra condition which helps us find the constant c. So we start as usual, and then once we are at the step where we have a c on the right hand side, then we use this condition to find c. So the equation is dy over dx is equal to x to the 6 times y minus 2. Dy over dx is equal to x to the 6 times y minus 2, and y0 equals 4. Okay, so now remember, when you separate, you should have the differentials in the numerator. So here dy is in the numerator, so we leave it over there and we bring the y terms alongside it. So the y term was y minus 2, so you divide by y minus 2. And x to the 6 on the right hand side, and then you move this dx, it comes in the numerator on the right hand side. And when you integrate both sides, the integral of 1 over y minus 2 is ln y minus 2 absolute, and x to the 6 is x7 over 7 plus c. And now we use the initial condition to get c. Y0 is equal to 4. That means x is 0 and y is 4. So substitute y is 4 and x is 0 in this equation. So ln 4 minus 2 equals 0 power 7 over 7 plus c. And ln 2 is equal to c. So c will be replaced here by ln 2. And therefore we get ln y minus 2 equals x7 over 7 plus ln 2. And that's what we have here. 7 over 7. ln y minus 2 is equal to x7 over 7 plus ln 2. And here they were not forcing us to write only the constant on the right hand side. Here they just said the solution is, and you are free to write in whatever form you want. So we just wrote it in the way we got it. Okay, so solve the initial value problem. Square root y dx plus x minus 4 dy is equal to 0. Y at 5 is equal to 1. So here first, let's write the equation. So this is the equation, and we first need to separate variables. So in this kind of situations, the way we do it is we just move all this on the right hand side first. So I'll just rewrite this thing. And I move all this on the right hand side, so it becomes equals to negative of this. And then you have a dx on the left side, so you bring the negative x minus 4 alongside it. So dx, or we can just bring the x minus 4 here and leave the negative on the right side, is equal to, and we have negative dy divided by square root y. Negative dy divided by square root y. Okay. And now when we integrate both sides, we know that the integral of 1 over x minus 4 is ln of x minus 4. So ln of absolute x minus 4. And now for the 1 over square root y, you can bring it up as y power negative half and apply the power rule. But since the 1 over square root x or 1 over square root y appears so often that I always teach my Calc 2 students to just memorize it so that you can save time. So the integral of 1 over square root y, you can just remember, is negative 2 square root of y. That's what you will get if you apply the power rule, as I said. So the integral of 1 over square root y is 2 square root y. And then we already have a negative. So it'd be negative 2 square root y. And then plus c. And the constant will be found by substituting 5 for the x and 1 for the y. So 5 goes in for the x and 1 goes in for the y. And so you get ln of 1. So 5 minus 4 will be 1. Or let's just write it. 5 minus 4 equals negative 2 square root of 1 plus c. And this is ln of 1, which is 0. So you get 0 is equal to negative 2 plus c. And that gives us c equals 2. So in this solution, you just replace c equals 2. So our solution will be ln of x minus 4 equals negative 2 square root y plus 2. Ln of x minus 4 is equal to negative 2 square root y plus 2. And that finishes the section.